All right, so we have another problem where we want to generate an expression that is equivalent to 5 to the power of 5 times 2 fifths to the power of 2 times 2 fifths times 5 squared, or 5 to the second power. All right, so what we want to do is combine bases and their exponents. So I see a base of 5. And so I have, we know that we're multiplying. So that means we're going to add our exponents. So 5 plus 2, and then I'm going to multiply my base of 2 fifths. So 2 fifths. And I have 2 plus 1. Okay. When we don't see an exponent, know that that's 1. Okay. So every number has an exponent of 1, unless we put a different exponent to it. Okay. Or next to it. All right. So what do we have? If we simplify this, we have 5 to the 7th power times 2 to the 5th power to, I'm sorry, 2 fifths to the 3rd power. We added those exponents. All right. And so this would be an okay answer for you to give it to me. This is simplified. But if you wanted to take it a step further, then remember you can go on and plug it into your calculator. So we're going to say 5y to the power of x, which is 7. And we get 78,125. Okay. And then we're going to multiply that by, let's see, we have 2. Oh, let me put it in parentheses. So I'll put in parentheses 2 divided by 5, because remember that's a fraction, which means we're dividing. So 2 divided by 5. We know that we're inside of the parentheses because we see our brackets here. Now close up the bracket, and we're going to put it to the power of, so yx to the power of 3. And that gives me, actually I can just put times 0.064. So when I multiply those two numbers, I think this was a 1, right? Let's see, 5 to the power of 7. Yeah, 78,125. Okay. And then we're going to multiply that by 0.064. And we are left with 5,000. Okay. So either one of those will be fine. Now I'm just going to go a different route and show you what it would have looked like if I wanted to write this all out. So I could have said, let me start here. 5 to the 7th power. Okay. And then we're going to multiply that by 2 fifths to the 3rd power. All right. And then what we would have here is going to be 5 to the 7th power. And this is the same thing as saying 2 to the 3rd power times 5 to the 3rd power. All right. And so remember, 5 to the 7th power, that's the same thing as me saying 5 to the 7th power over 1. Right. And then I'm going to multiply that by 2 to the 3rd power over 5 to the 3rd power. So notice that I have the same base, 5s. Right. So I am going to go to my numerator and put in 5 to the 7th power. And because we are using division, if you have one number in the numerator and one in the denominator, you're dividing. So we're going to subtract. So I'm going to take out those 3. And then, so that will be taken care of. And then we'll still have multiplied by 2 to the 3rd power. And we don't need the 1, right? We know every number is always over 1. So what does that look like? Well, that looks like this. 5 to the 4th power times 2 to the 3rd power. Okay. And if you plug that into your calculator, we should still come out with the same amount. So 5yx4, that gives me 625. So 625 times 2 to the 3rd power is 8, but I'll plug it in anyway. 2 to the 3rd power is 8. So you're going to multiply 625 times 8, and you see that we come out with 5,000. So we can do it a few different ways to show our answer. So this is an equivalent expression. 5,000 is equivalent expression. And then 5 to the 7th power times 2 fifths to the 3rd power is also an equivalent expression for this one.